Sanjay? Yeah, thanks, Siddharth. Yeah, hi. So let's, Kavya, let us go on to the next slide, please. Yeah, so what we are trying to do here is, talk about AI and its relevance in today's world and what opportunities it actually gives. And, if you don't play this AI game, what would actually happen to us? Do we become a part of this large growth that is actually happening in India? Then industry 4.0, okay, how so many free trade agreements India is signing with so many countries. So now what is that opportunity for us? What does it mean? If you want to grab that opportunity, how industry 4.0 can actually help us? And then next tech, which is part of CASIA, how are we focused that we can enable MSMEs? Please remember this. We are not talking about big companies who have money, resources, talent to implement some of these particular things. We are talking about how Next Tech, which is a program for innovation from CASIA, how will this enable MSMEs to actually implement or adopt AI or Industry 4.0, etc. And then we'll open up the floor and have a Q&A. Yes, please. Next slide. So my name is Arun Prasad. I have over 35 years of industrial experience, out of which 25 years as an entrepreneur. I'm basically a mechanical engineer. So I am a certified Six Sigma black belt, but I have more than around 350 project experience of implementing Six Sigma all over the world. Then I do have international experience. I've worked in the US, I've worked in Germany and Japan. And I have around 25 high-tech product experience where I was either a part of the architect or I was the product owner. Okay, so under me we have established around 21 tech products. Yes, please. With this, let us start off about AI and try to understand in layman terms. I've tried to demystify because we are hearing a lot of things and sometimes it is difficult to understand. So I've tried to simplify this so that it is easily understood. Okay, yeah, let's do this. Yeah, basically what it means here is there are a couple of definitions here. You can read this through Wikipedia. So the highlights here are ultimately it is a machine, okay, which has, you compare this with human intelligence. They're trying to build learning. Can it learn? The computers can learn today. Can it reason? Can it do problem solving? Can it create a perception or an opinion just like how human beings do? And can it help in decision making? Now, all of these things put together is kind of what is called as the artificial intelligence. So what it means here is, just imagine you have a smart person in your organization. Today, it's so difficult to get talent and retain talent. Now, just imagine if you have a machine which does all of this, which is almost like an assistant, and it does not ask for leave, it does not ask for salaries, it does not ask for so many things, right? So that's what is artificial intelligence. So now the world has adopted this, they have understood the value, and how does it help us? And to MSMEs, it means a lot because MSMEs also are struggling with trying to attract talent and retain talent. And some of the organizations, which are dependent on labor are really suffering. And so it's kind of a blessing for MSMEs. So hopefully by the end of this session, you'll be able to understand that yes, it's a perfect fit. More than the big companies, it is very good for small industries basically. Okay? Then if you look at the Oxford Dictionary, it's similar. It says exhibit or simulate intelligent behavior. By what? By the machines basically. And one of the concepts that you would have heard is machine learning, ML as it is called for, which is the cornerstone for an AI. And then it is linked to a lot of data. If you don't have data, you don't have this intelligence. The more the data, the better the machines can learn and deliver. Okay. Is my voice okay? Am I able to make sense, please?
Yes, absolutely.
Yeah, thank you, Sanjay. Yeah, let's get on to the next slide, Kavya. Okay, so now in a nutshell, what is natural intelligence? So let us try to understand, out of which human intelligence is one part, animal intelligence, dogs are smart, crow is also smart. All of them have intelligence because in the center of the whole thing, they have what is called as a brain. Okay? And this brain becomes smart or can process few things only if there are signals which comes in. So what makes humans very smart is we have all these five senses that are available. We have a nose which can smell things. So now just imagine if you are in a very dark room, you can't see anything, it is pitch dark and there are no sounds, but you can still smell if there is a smell that is actually coming in. So either it can work in isolation or it can work in tandem, and this processing of these signals actually happens in the brain, and that's how it gets transformed into decisions, or it gets transformed into some kind of opinion or learning, or any of those particular things are actually happening because of these five sensory organs that we actually have, which are smell, hearing, we see also, we touch also, and then we can taste. So now the science of trying to mimic human intelligence is what is, broad perspective called as the artificial intelligence. Yeah, let's go on to the next slide. So now if you look at it, a pictorial, this thing is a machine, but trying to make it intelligent, and then this becomes artificial intelligence. So ultimately a machine need not be, it could be a car, for example. It could be something like, your smartphone, for example, is a very good example of how, why do we call it smart? Because it has so many capabilities of doing things. Okay, so the processing of all of this is the brain basically. That is where we call this as, you put it across in a server, or now if you're talking about chips now that are there which can do processing very quickly, right? All of these things are called as machines, or it could be today cameras. What it does, majority of the cameras are dumb, right? It just captures the video or an image. It does not know anything to do. If you are able to build a little bit of intelligence where it can do face recognition, okay, or it can find out an alert, can it find out that you are not, you might fall sick because it is able to read your face and then identify certain traits which can result in you falling sick, for example. Such kind of things is what we are talking about as smart appliances, or some of those particular things which is called as AI. And the most popular, of course, is a self-driving car, as we say, where you don't need a human being to do that. It can follow all the rules of the traffic, ensure safety, and still can reach you from point A to point B without a human intervention, basically. Now, in Bangalore, we have one case, which is the yellow line. Of course, right now, we don't have the coaches which are there, but this whole thing, how does it make it different from the, green line and the purple line here is, these are driverless. The whole signaling system that has been set up there is to enable driverless metros, the yellow line specifically. Of course, we are still waiting for the coaches to actually come in. So they're running this particular thing, but it can be. So the smartness here is it knows when the station will come in, when can it stop, how much time to stop, when to accelerate. So all of those particular decisions are being taken. And that's a classic example recently of what actually happened in Bangalore. Yeah, let us get on to the next slide, please. Yeah. So now, yeah, sensors to mimic human senses. For example, we have an eye. So there are robotic eyes now, for example. Okay, very nascent. If you look at in the world today, the biggest limitation today for a robot or any of those particular thing is the ability to see. So there are no cameras as such which can replace a eye. So that's how what they do is they try to bring in what is called as a sensor which can proximity. So it's a proximity sensor. So they take a camera and put a proximity sensor, and then it almost becomes like a human eye. Okay, so still the cameras are not smart enough to replace a human eye, but still a lot of work is actually happening. This is where what is called as computer vision. So a lot of work is actually happening. Billions of dollars of research is actually happening on this, and this is a lag when compared to the others basically. Now with regarding to touch, as you can see, there is an image there where you can put in a glove, right? So now suddenly what all your gestures that you are doing or what you touch, this glove is kind of helping you. So anything that is in movement versus this, of course, a long way to go. For example, now, suppose we are using robots in a disaster recovery or in a place where, let us say, a building has collapsed or something like that. The robot does not differentiate. It is not able to know whether it is holding a human hand or a steel bar. Once it does not know, it just pulls. Now you know what could actually happen to a human arm if it is not handled properly. So now there are some limitations. But again, lot of work is actually happening. Materials are actually coming in. New materials are being done. Okay, just to actually improve this particular thing and raise the sensory this thing, and hence if the input itself is not there, then how can the anything can actually process it. So now a lot of work is actually happening. Same thing with regarding to smell. With regarding to smell, the same issue. Now what actually happens, there are sensors. For example, just look at this. Majority of the times we get so angry when we go to public urinals or public toilets because the smell is, you keep wondering why can't people smell this and clean it up. Now, in such places, there are aromatic agents that are actually available, which can send out sensors, which can come back and give a signal saying that this thing is actually smelling. Okay, the same cases, if you look at it, there are two positions which are fantastic in the world, which are paid the maximum. One is a tea tester and the other one is a liquor tester, wine tester, for example. Okay, these two people are paid so much because aromatically they can sense so many, different kind of tastes basically. Now they're trying to do the same thing by way of sensors and trying to come and do this particular thing. So there's a lot of work that's actually happening there. Of course, long way to go. Then, of course, we have the ears, the way we hear. And then there are so many speakers that are actually available. The one that I am wearing right now is a wired one. There are wireless ones. There are something which is called as near ear speakers and stuff like that. So many things. It can actually distinguish things. It can suppress noise, right? There are so many things that are actually happening, which is trying to improve the signals of hearing basically. Okay. And of course, the last one is taste. And I did talk about those particular things. Okay. Yeah. Let's go on to the next one. Yeah. Now, if you look at it, can you go back one more? You pressed twice, Kavya. Can you go back? Press only once. So now, if you look at it, the broader thing is what is called as artificial intelligence. Within that, the most popular approach was machine learning. Okay, machine learning did actually happen, and that is one thing which started the journey towards artificial intelligence. Then there was a subset of that which is called as deep learning, the ability to get into much more deeper. For example, this is classically what is called as a chess game. If you're playing against a computer some 30, 35 years before when you started, you could play against the computer. And majority of the times the humans were winning. You could win a computer when you're facing computer as a opponent basically. But today it has learned so much. It knows all your moves and it is much more smart. It's very difficult to play and win against let us say a computer when it comes down to chess. What was there in the, what was happening behind? It was learning. With every game that was played, it was trying to learn. And that is what deep learning actually happens. That's a science within the artificial intelligence where, of course, this is not new. It is actually there for some time, basically. But what made it very popular? Suddenly, in the last couple of years, everybody is talking about AI. Suddenly, as though the whole world has suddenly woken up. What changed? The science that changed the approach to AI and made it so popular is what is called as generative AI. And this is the science where people could actually do something to change. Even common people could actually do this. You didn't require coding, you didn't require mathematical skills, you didn't require statistics, you didn't require to know psychology of people, blah blah blah, etc. Even with all of that, a common man could actually interact with a computer and do so many things. And that woke up the world, and that is what is called as the generative AI. So in generative AI, what actually is the one that makes it so popular is what are called as foundation models. Okay. Broadly, there are two types. One is what is called as an LLM, large language models, as it says. Okay, that was the one. So what they did was they trained the computer with billions of data points. Okay, now you know Chat GPT, which is very popular. They spent decades in training the computer. Okay, the foundational models that actually came in. And now there are many of them. So you have Grok, which is Elon Musk's this thing, OpenAI's ChatGPT. You have Gemini, which is of Google. And then you have an Indian context also called as Perplexity AI. In my previous avatar, I had something to do with an Indian LLM that we were trying to build, what was called as Hanuman AI. So like this, so many people have been trying. Then you have Claude and stuff like that. Okay, so now there are a lot of LLMs that are there. Each one has got their flavor, their approach to life, but in broad they do the same basic thing. So you can just put a description and ask an image to be created. Till now, either you had to draw, sketch, caricature, or you need a camera to take an image. But now there is an alternative way of generating this, wherein you can ask the AI to actually give a broad description and then ask it to create an image. So audio, video capabilities, etc. These are called as deep fakes, as you can actually see. And on the other side, chatbots, where there is intelligence, you can converse with the machine, where it can actually come back and then give some of those things. So now suddenly this is what is the layer. So today's world, contemporary world, is actually bombastic, or people are feeling, or a common man is talking about AI or some capabilities with regarding to AI is because of generative AI. Okay. Yeah. Okay. Now, if you look at technology adoption, okay, now bottom line you can see AI. So now if you look at it, AI did not come overnight. Okay, so in 1980s, 60s itself it started. Okay, so now the adoption is like this, normal AI basically. Okay, now yes, please, next one. So now if you're talking about machine learning, again, it did not start now, 1970s onwards, but suddenly there was an uptake in 2000. If you see, the graph went up a little bit. Then deep learning, yes, it became extremely popular somewhere in the early 2010s, and then it actually went up. No, no, just go back. Yeah. Now, if you see generative AI and you see how the graph is, it suddenly went up, and that is what is surprising the world, or it is capturing the attention span. And now suddenly the capabilities of AI and the use of this has actually accelerated, and people are able to appreciate that AI can be done and what it can do. I think in your lives you must have used, we were so used to using Google search bar, right? That is what we used to do. That used to be a go ask Google. So if you have a doubt, just go. You want to ask about temperature about Bangalore, just go there and say temperature of Bangalore, and then it used to give some. So we were so used to getting this, but AI went one step above. It did not just give you collate results for you and then show it as a list. It actually went much more deeper, trying to understand. You can have a conversation. So the conversation that you have with a machine typically is what is called as a prompt. In a Google bar, you used to write something and ask for a result. The same thing here is what is called as a prompt. This is also kind of called as prompt engineering. So there is a new class of people who are required now, who are smart in understanding how AI works and then does something to get a useful information out of the system basically. So generative AI has made dramatic changes to the world, and the world will never go back to before generative AI. This is there. This will be the way going forward. This can only improve. Just like how so many businesses have changed the way post COVID versus before COVID and after COVID, it brought in dramatic changes in business processes. The world changed. They adopted new ways of doing businesses. The driver there was COVID. Now, generative AI, there is an era before and there is an era after generative AI, and the world is not the same. It has changed forever, basically. Okay. Yeah. Okay. So now, if you typically imagine how this would actually look, on the left hand side, you have all these sensors basically. Okay. These sensors, what do? They pick data, right? They send out data, data acquisition actually happens. And this data gets processed basically into something. It has to mean something, for example. Okay. And then this processing, there is an output out of this. And this output basically is nothing but information. Okay. This information means nothing if does not feed into decisions, which does not result into decisions, and this decisions results in some action, and all of this happens in real time. There is no dwell. If some of you have seen this before or familiarized with some kind of computer systems, if you want to generate a report, okay, sometimes before you go home in the evening, you used to set up and ask for a report, and then it used to work through the night. And next day morning, when you come back for work, the report used to be ready. Okay, so now that was one kind of way that people used to get some action or something like that. Today, it is real time. And of course, the definition of real time changes. Suppose ISRO is launching a satellite, their real time is almost nanoseconds basically. The data that is going between the rocket and the base station, this keeps moving at enormous fast rates. Something which we have all used, Google Maps, for example. Okay, if you look at Google Maps, the data between your phone and the satellite talks to each other 8 times every second. 8 times every second. That's the speed at which your machine, which is your phone, and the app, which is enabling this, which is called as Google Maps, works with the satellite basically. So now that's the speed at which things are happening. Same case here. You don't, in today's world, nobody expects something to actually happen over a period of time. And our next generation, which is the Gen Z, they have no tolerance. They don't have, patience basically. So now that's the world that we are going into basically, because they are the people who are going to take the world to the next level basically. So now more and more applications, more and more processing. Now, if you will be surprised today, if the smartphone that you have with you, okay, is sometimes more powerful than a server because it has octa core. It can do multitasking. It has so much amount of RAM that it can actually come back and do so many things parallelly. That's how you see today. It is so difficult to live without a phone because that has become your go-to device, right? Why? It can help you do things in real time. Now, if you have actually started looking at it, there are talks about what is called as quantum computing. What does that mean? One of the reasons why ISRO is so successful is we have our own supercomputer. The way we launch the rocket, the way we monitor, the way we control hundreds of kilometers away from Earth, still we are able to control and manage because India has a supercomputer. What is a supercomputer? Tremendous ability, processing ability, speed at which we can actually do. Today, you know what? Quantum computing can actually do the same thing, capability to you and me. So that means today this itself has made us extremely, your smartphone basically has made this enabled human beings to do so many things, information, last mile connectivity, getting this, getting that, make payments, etc. Suddenly you see how much disruption has actually happened. About 5, 10 years before, the only way if somebody comes back and says, oh yeah, I have a credit card, I have a debit card. That was what life was. Today, at least in India, if you see, of course, in the US, it is still there. Without a card, you can't do anything there. Still, their systems are. That is how we have leapfrogged. India has actually gone beyond this because we have what is called as a UPI. Where why? Because we have a phone. And with that particular phone, the speed of processing, so the payment which used to take 2 to 3 days now actually happens in real time. So now, so more and more business processes are going towards real time because that is what the market is actually expecting. Yes, please. Let's go on to the next. So now, if you look at data engine processing, okay, now if you see there is one word here called as the edge. Actually, what is edge? The ability to compute. You don't have to do all this processing in a server. It could actually happen at the device level. For example, it could be at a smartphone, blah, 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 etc. Now, okay. So now if you look at face recognition feature that is available in your phone, that process is not going to the server. It is actually happening at your device. That is what is called as edge. You're processing tremendous capability of processing some of these particular things on your device side is called as edge computing. However, anyway, there are so many different algorithms which are there, and you can see there are, which does various things. So I've just given few examples, 5 in each of them, but there are many more basically, okay, which helps organization in doing so many things. Of course, this is the mathematics part of it. People, when they are creating a device, they need to come back and figure out what to do, etc. This, of course, requires, computer science skills. This requires mathematics skills, and then this requires business knowledge as such. All of those particular things are there, which makes this magic of converting something to something, an output basically. Yeah, let's go on to the next. Okay, so the information could be through signals, it could be through alerts, it could be through infographics, it could be through graphs, it could be through scorecard basically. One signal could be something which can be picked up by the other signal. For example, now just imagine I have been to a factory in Germany, which was this Volkswagen plant, a new plant that was actually built. Now, there are only 5 people in that plant. All of them are behind a glass. In the shop floor, there are no people. So now there is an AGV or an automated guided vehicle which comes in, stands in front of a machine where this thing post processing or post machining, the hand is actually, the robotic hand is actually putting on the vehicle, and the vehicle is going to another machine. It knows exactly where to go. Hundreds of machines like this and hundreds of this thing, and there were no people. It was almost like magic, a sci-fi movie. And the 5 people who are there, a similar plant with same capacity, 550 people working in that plant. Now this is a classic example of an industry 4.0 organization. Okay, so now, yeah, let's go on to the next one. So by the way, signals, more and more machines will talk to machines. For example, we are already doing this. If you have a Wi-Fi at home, you have an adapter, right? Once you connect this, you go out of range, you're going out of the house, it automatically cuts. And the moment you actually come in into the range, suddenly they connect. You don't have to do anything at all. So one machine called as a Wi-Fi adapter is talking to your smartphone, and they're talking to each other without you knowing. Same way, if you are using this fast tag, you have a sticker on your windshield, and as you actually come closer to in the booth, the boom recognizes this, and then what actually happens, suddenly you see the machine talking to each other, the sticker. Okay, and then it is not only that, it's debiting an amount from your wallet basically. So all of these are actually happening almost in real time, right? So now that's the point, signal, and that is what has changed. IoT, as we call Internet of Things, which is really another big technology that has redefined the way the world is actually working, which is helping us more go towards autonomous systems basically. And decisions, of course, which we know has got this. And now all of this will be computed in real time. All this will get computed. For example, just imagine you're in a driverless car. And by the way, I had a chance to sit in a taxi. It is run by an organization called as VEMO, VEMO. Okay, those are taxis that are run in the US. So in Austin, in this thing, Texas, I had a chance to sit in a taxi. Wow, wow, man, I felt more safe in that car versus somebody who's driving, because it was following all the rules. It knew when to stop. The moment it sensed the red light, it used to stop. Somebody comes in front, it used to stop. It was fantastic. And it was kind of memorable, almost like a sci-fi feeling, basically. So now in all of that, this decision making is actually happening in the back end. And there are algorithms again for this. Typical things called as decision tree or something like, if this comes in, this is what it means, and this is what you have to do. And in real time, it actually does this, because the response time, all of this processing actually happens in few microseconds. Okay. Yeah. Let's get on to the next one. Okay. Now, without action, it means nothing, right? So ultimately, all the signals, whatever we are doing, information, decision has to result. And that's how in a wireless or in a driverless car, what is it that is actually required? The decision or the action has to stop if there is a red light. So it should enable those particular things, right? Now, suppose the vehicle in front slowing down or they break down, the vehicle behind also should slow down and break down. That is the action that is actually required. Now, all of these are actually happening in real time, and all of this actually happens in microsecond responses. That is where the computing power that is actually required is becoming more and more critical. Yes, please. And applications, some of those particular things. I did give you an example of Google Maps, Uber, the whole model, Ola, etc. They work on AI basically. Autopilots in flights, driverless cars. Today, emails are also becoming extremely smart. They can actually classify, they can do things. Okay, Google Photos, for example, suddenly they come back and then relate you, they stitch some photos of your same face over time. And if there are certain markers inside the image, for example, birthday, happy birthday, or there is a cake or a candle or something, automatically it categorizes that into festivities or birthdays basically. All of this the system is doing on its own. Okay, email type assistant. Today, when you see, I don't know how many of you have noticed this, when you're typing in your Google Mail, it is prompting you, it is forming sentences for you. You just have to start, press a tab, and the whole sentence is actually done. It has become an assistant now. You can write faster now. It is able to understand or trying to, forecast what you're going to say in that particular sentence, and then there are helping things form. So email type assistance, anyway, email smart categorization, plagiarism checkers, for example, especially large projects, or if you have applied for a patent and if they want to know whether there are similar patents, etc., they are using those particular things where they come back. They're even giving percentages of how much plagiarism has actually happened. Even universities, when people are submitting their projects, they actually use this particular tool basically. The chatbots, of course, we know so many of them. Earlier, we used to have BPOs. BPOs have all disappeared now. Who has replaced those jobs? These are those chatbots basically. Okay, adaptive learning. Okay, simulation related learning. So there's so many things that have actually come in here. Fraud detection, especially in banks and in insurance companies, basically credit decisions, whether you're credit worthy or not, that is also being done by machines now. Facebook tagging, you just, somebody is there, you don't even know, and then suddenly you say, how do I know these particular people? Because there is a tagging facility where through which you are able to know that, oh, who this is, this person, right? Online shopping, of course, it needs to go a little more this thing, but basically a lot of intelligence is actually coming out of this. These are few examples now. Okay, going forward, there are much more. Especially now, you can create something. There are codeless applications where AI generates code. In some cases, they are called as low code coding. Now, so many things are actually coming in now, wherein applications and stuff like that. And this is the world that we are getting into, guys. So it is very important that AI, we should not ignore it. And it is too expensive to ignore this, especially MSMEs. Okay, let's get on before. Okay, look at the market size, guys. Why I'm telling you, please don't ignore this is it is going to reach close to $3.5 trillion by 2033. This will be the size, biggest change in the market, AI, okay, which will grow at 31.5 compounded annual growth rate, year on year. Okay, this is one of the estimates. The same way, 4.8 trillion. Somebody else has estimated this. Basically, it is a United Nations. Okay, 25-fold increase, and we have seen this also from an India perspective. If you look at it, India is growing. We have crossed $4 trillion. We will become the third largest economy and reach $5 trillion very soon. Do you know a jump from 4 trillion to 5 trillion, how much opportunities it throws up? Now the business will come in. Sadly, in India, what actually happens, all the biggies who have money, who have talent, access to talent, etc., they grab in. The Mahindras, the L&Ts, the Tatas, the Reliances, they come in because they have money, they take the opportunity. What happens to the other people, basically? Today, if you look at it, guys, of course, I'm not trying to demean or say something. I'm just coming out of trying to emphasize what is the opportunity. If you talk about China today, okay, 8 to 10 people, which is classic micro industry as we call in India, okay, they make these kind of products, smart watches, smart rings. They are not done by big companies. They have been able to adopt technology into micro levels, at the grassroots levels. Here in India, the same products are done by large companies. Technology has to peter down, it has to come down to the grassroots, and that is where the MSMEs actually come in. And it's an opportunity because MSMEs are in pain, basically. Talent, people, money as a this thing, but no shortage of ideas. Lot of ideas. Our frustration is, boss, I also had thought about this 10 years back. Look, that company has launched the product now. I don't know how many, at least once in your lifetime you would have faced that. Sorry, I'll use a little bit of Kannada. ನನಗೆ ಹೊಡೆದಿತ್ತಪ್ಪ ಇದು 10 ವರ್ಷದಿಂದ ನೋಡಿದ್ರೆ ಆ ಪ್ರಾಡಕ್ಟ್ ಯಾರೋ ಲಾಂಚ್ ಮಾಡಿದ್ದಾರೆ ಛೇ. You all will face that because there is no shortages of smartness, but we don't have enablers to actually convert this idea into something tangible. So this is one of those particular things, but it's a huge opportunity for MSMEs basically. That's okay. Next. Okay, typically the skills that are required if you want to build this or build some kind of a product or something like that, these are few important skills that are required in the uh, you know time that you're building your product or a service basically. Okay, these are the skills that are actually required. Okay. Okay, so these are few things basically that are required. So one is an idea, This is called as an ideation process. That itself is a process to convert into tangibles, either a product or a service. And this is what some of the skills that are required in this particular whole thing. Yeah. Yeah. So now even here, for example, we have already seen traditional jobs are dying, but it is getting replaced by new jobs. So the change of the talent pool itself will dramatically be different. We are seeing this more and more. There was nothing called as a prompt engineer before. There was nothing called as an RAG engineer before. These are all new things that were not there at all. Now, these kind of skills is what is going to actually help in the future. So this is also one thing. So that means we need to play this game somehow. India as a country has to play this game. The world as an entity has to play this game differently, because this is transformational. Every organization, every country, the whole world, the way they are going to talk about this, because it has social impacts. Okay, it has impacts on resources. By the way, now you won't believe this. If everybody starts using, instead of Google Chrome, what is typically called as an AI assistant, we don't have energy. Total power that is getting generated in the world is not enough to support the planet for an AI initiative yet. You require 3 to 4 times more power than what is actually available today. So the world also need to figure out how do we ramp up our power generation, for example, to do this. It is not just data centers. Data centers have been there. That itself are power intense. Now you need so much more processing power. So now, where is the power? Okay, suddenly you see the world is struggling. So now governments across should come down, have a strategy, and this is the way. So the adoption of AI will actually depend on governments taking initiative, the world recognizing the benefit, organizations understanding the benefit and the change, and people. Even people's behavior will change. People are driving, the way change. We have seen now, especially the Gen Z, which is happening now. If you ask my generation people, when we were came out of our graduation, what are your 5 important things that you want to achieve in life? We used to say, I need to build a house, I need to have a car, I need to find a good job which allows me to travel around the world. Okay, blah blah blah, like that. There were some things, but today ask for a Gen Z, house is not even in their list, because they already have a house. Okay, car. Who has to go through this janjat? So if the worst case, they will ask for a Ola or a Uber. Otherwise, they use the metro. Now in this list, they don't have anything, but new things have come in. Every year, I want to change my phone, right? They are all become gadget related. So many things come back, buy this, buy that. So that is where the focus has actually shifted. Now, once the whole world buying patterns have shifted, now generally, how should the world adapt? Basically, how should organizations adapt? That's what is the challenge that we need to actually solve.